All right, welcome to The Explainer. Today we've got a critical briefing for every CTO out there because, let's be blunt, your database architecture is facing an existential threat, and it's coming from AI agents. This isn't some far-off trend. This is happening right now inside your infrastructure.
So get this, there's a new user taking over your cloud right now, and the scale of this takeover? It's staggering. We're talking about over 90%, of new daily database clusters being spun up, not by your dev team, but by autonomous AI agents. This is a huge deal. It's basically a historic shift, where the main user of our data infrastructure is no longer human.
Okay, so how in the world do we deal with this? That's what we're going to map out today. First, we'll get to know this new user and why they just completely shatter our old playbook. Then, we'll dive into the non-negotiable architectural demands they make, how to survive the cost explosion that's coming, and finally, how this all leads to a whole new way of thinking where your database basically becomes code.
All right, first up, this new user. And it's so important to get this right. This isn't just a tech shift. No, it's a fundamental change in behavior. It's driven by a user that plays by a completely different set of rules.
Just look at this comparison. It says it all. Human developers, right, we're deliberate. We batch our work, we try to operate during business hours to keep costs down. AI agents, totally different beast. They are relentless. They're working 24/7, just churning out code, changing schemas, spinning up infrastructure. It's this chaotic, experimental intensity that our systems have never, ever had to deal with before. They don't slow down, they don't take coffee breaks, they just build.
And it's this relentless new user that just completely breaks the models we've been using for the last decade. The old playbook? It's broken. The rules just don't apply anymore.
You see, the critical thing to grasp here is that when we talk about scale now, we're not just talking about more rows of data. That's old school thinking. We are facing a multi-dimensional scale explosion. Think about it less like you need a bigger warehouse and more like you're trying to manage a million pop-up shops. Each one has its own inventory, its own layout, and they appear and disappear in a matter of minutes. That's what we're dealing with. Millions of schemas, contexts, and branches all happening at machine speed.
And this slide right here, this is where the math gets absolutely terrifying. Just imagine a platform with 100,000 users. If each of those users runs, say, 10 tasks with agents, and each task tests 10 different branches, poof, you're suddenly managing 10 million databases. This isn't some hypothetical future. This is the new operational reality right now.
Okay, so to handle this new reality, these agentic workloads, they come with a list of non-negotiable demands for our data infrastructure. And let me be clear, if your architecture can't meet them, it's not going to bend, it's going to break.
So surviving this means you need 5 core capabilities. We're talking about rapid provisioning, spinning things up in seconds to keep pace, true hyperelasticity for these crazy bursty workloads. You need agility for constant schema changes, deep contextual intelligence you even know what they're doing, and you need cheap, instant branching for their non-stop experimentation. Our traditional systems, they were never, ever built for this kind of churn.
Let's dig into that first big one, hyperelasticity. Agents are creating thousands of temporary environments that might only need to exist for a few minutes, maybe even seconds. To handle that, you absolutely must be able to spin up and tear down these isolated environments in the blink of an eye. And the only way to do that? True compute storage separation. Your architecture has to be able to scale compute totally independently from storage, instantly. That old monolithic model, it just can't keep up. It's toast.
And then there's agility. This is a big one. Agents will not negotiate with you. They don't care about your planned maintenance windows. They will just casually generate schema blocking operations as part of their day-to-day experiments. And if your database blocks them, they're not going to file a ticket and wait. Nope. They'll just abandon that experiment and spin up a new one. What this means is that non-blocking schema evolution is no longer a nice-to-have. It is a fundamental table stakes requirement.
And all of this, naturally, brings us to the issue that's probably keeping every tech leader up at night: the brutal, unavoidable economic reality of agent-driven development.
Because agents operate with this insane efficiency that just dwarfs human engineers. Cost becomes the single most dominant constraint in the entire system. Seriously, the most important question you can ask about your database is no longer how fast is it, it's how gracefully does your database decay cost when it's under massive, massive scale.
And this chart, this just illustrates the problem perfectly. The old way of doing things, paying for capacity for all those idle instance hours, that's a fatal flaw now. In a world of these bursty, temporary agent workloads, you are just paying for waste. I mean, you're often paying for servers that are doing literally nothing 90% of the time. The new model has to be usage-based. You pay only for the actual work being done, period.
So, to survive this financially, your model has to be built on these 4 specific rules. 1, your costs have to be able to scale to 0, because agents will have quiet periods. 2, you must pay only for precise usage. Think request units, not instance hours. 3, database branching has to be incredibly cheap, almost free, to enable all this experimentation. And 4, you need economic governance. I'm talking per agent metering, so one runaway agent can't bankrupt your entire project.
Okay, so finally, this whole shift from the user to the architecture to the economics, it forces us to completely redefine our mental model of what a database even is anymore.
You know that old metaphor of the database as a static central warehouse? It's dead. It's over. The new metaphor is code. The database is now this dynamic, programmable substrate. It's something that agents can branch and refactor and test and merge, and then just discard, just like a developer working in a Git repo. It's alive, it's constantly changing, and it's completely automated.
So the crucial question, the one you absolutely must take back to your team, is this. Is your current data infrastructure a passive warehouse designed for humans? Or is it an active, programmable substrate, ready for the era of software that builds itself? Because that era, well, it's not coming, it's already here.